Hello and welcome back to Emergency R, where we're trying to get you going as quickly as possible with your data so that you can work with it in R. The learning objectives for this video is that you'll be able to investigate individual columns, including finding unique values and visualizing distributions of numeric values. You'll be able to identify rows that have outliers. You'll be able to view and edit the column names if you want to change the names of any of your columns. And you'll be able to preview specific rows and columns from the data frame. So if you followed along with the video for importing data from spreadsheet software, we created this CSV file that we could import into a data frame in R. And if you didn't follow along with that data, or if you just want to get the file, there's a link in the description to a GitHub site where you can download it. There's also a table of contents in the description if you'd like to skip ahead or go back to any particular parts of the video. So to import that file, we wrote this command read.csv, and we assigned the output of that function to this object called MSI data. So if I click here to run that command, now I have this table MSI data. Over here I can take a quick little preview of it. Over on the left here, right? And before I showed you the str command, so if we run that, it gives us some basic information about this data frame. So we see the 8,143 observations, 20 variables. We can see the name of every column listed after a $sign. And we can see what data type we have in each column and a preview of the first few values. So we have some columns that are integers, some that are characters, and some that are numeric, which means a non-integer number, like a decimal. And if you recall from last time, we discussed how you should very carefully check these data types to make sure they actually match what you expect for the data. Another really useful function for exploring your data is called summary. And we can run summary on the whole data frame, but it's going to produce a lot of output, which might be a bit too much to use at once. So we can also run it on one column at a time. And the way that we extract columns is with the $sign. So I type in the name of my data frame, and then say I want to get a summary of location. I type in the name of that column. So the name of the data frame, $sign, name of the column. And now I'm going to click run to run that line. You can also put your cursor on that line and press Control Enter to run it. So anyway, in the summary here, we learn how long this, we call it a vector because it's one column, so how long this column is or how long this vector is, and what type it is. Something else I might want to learn about character data like this, about strings, is what are the unique values and how many times do I see each one? So I can use the table function to get that information, and I'm going to put this, copy and paste this same code that I used to extract just that column. And so I'll hit Control Enter to run that. And so I see I have these 6 unique values, and I have a count of how often I see each one. So I can also do summary for one of the numeric columns as well. So say I want to do summary, let's pick column length. And if I run that, it gives me more of a mathematical picture of it. What's the minimum, what's the maximum, median, mean, how many missing data points do I have, which is what this NA stands for, is how many missing data points there are. Right, so that's some useful information, and I probably wouldn't want to do a table of this. I'll show you what it will look like if I do. Right, there are going to be lots and lots of different values, and so it's not quite so useful to count up how many I have of each. But what I might want to do is a histogram instead. So I type HIST, and then I'll copy and paste in my code that I use to extract that column. And there I get a nice histogram of comb length. And that's a very good thing to look at, just because if you have extreme outliers, something might be going on with the data. I mean, I've had it where, different people recorded it in different units, and so I see these, two completely different distributions, and that alerts me to something that's going on that I need to look into. Right, and that summary was also pretty useful because I see the minimum and the maximum, and if those don't seem biologically possible, I know I need to go look at that data. So let's take a look at what happens when I examine a different variable like basal circumference. So $, and then if you recall from the other video, I shortened that to bcirc, so it'd be easy for me to type. So I'm hitting Control Enter to run that, and I see I get a pretty wide distribution from 1.6 all the way up to 916. And if I look at the median and mean, they're a lot closer to the minimum than they are to the maximum. So let's take a look at the histogram of that. Control Enter to run it. Right, and here's a case where I have what almost looks like a normal distribution, but then I have some really extreme outliers. In fact, I can take a look at what happens if I log transform it. So I'm inside this call to the hist function, I'm going to type log and then another parentheses, and then I'm going to put my basal circumference column inside that log. And so I'll hit Control Enter to run that. And that's a little bit better. But still, right, I want to know, maybe take a closer look at these, say that are over 300 maybe. And the way I get the numbers for those rows, I can use a function called which. Right, because there were, if you recall, there are 8,000 rows in this spreadsheet. We don't really want to spend our day scrolling through it. So I'm going to say which, and then the basal circumference column, and then greater than 300. So I want to know which ones are greater than 300. And that then gives me some numbers that I can look at. So for example, those first two numbers were 150 and 175, so that means rows 150 and 175. So we can go back into our spreadsheet to take a look at these. I'm just going to freeze the top row so I can still see my column headers. So if I scroll down, and it's going to be 151 instead of 150 because Excel is counting the header row and R is not. I can see that for this sample, yes, there's a basal circumference over 400. If I go down to 175, this one also has a basal circumference over 300. Right, so I can start to see some of the samples that were my outliers. In fact, say I wanted to get the entry names for that. So $entry. And because this is the emergency R, I'm not really explaining to you the fundamentals of why I'm doing it this way, but if you watch some of the other programming videos, we'll take our time through these sorts of topics. So, oops. You know what? I'm also going to nest this inside a which, because if there was missing data, it kind of propagated through and then I got all these missing data from my output, but which will ignore the missing data. So I'll hit Control Enter now to run that. Okay, and now I get some information about exactly which samples had those really high values for basal circumference. And biologically speaking, that's because I had a few samples that were a different species for most of them, and they differed very much in how much they spread out. So that's why these numbers are different. So now I'd like you to pause this video for a few minutes and practice what you just learned. So if you're working with the same spreadsheet, I'd like you to determine which columns are better summarized with the table function versus which ones are better summarized with the hist function. And for those where you do make a histogram, do the data appear more normally distributed if they're untransformed or if they're log transformed? Now, if you're working with your own data set, please take a few minutes to explore it using the functions that I've shown here. Maybe identify some outliers, maybe identify some columns where the data type didn't get imported correctly if you haven't already done that. So here are some examples of what you could have done for the exercises. So if I look at, say, the rep column, which was an integer, if I do a histogram of that, right, that's not very helpful because there were just 4 values. So I might want to do a table of it instead. Right, and then I get a count of how many times I saw each of those 4 values. Now for a value that might look nice transformed, let's look at yield. So if I do a histogram of yield, I get something where there are a lot of very low values and some very extreme values. So if I copy and paste that same line and put in a log, transform that, that looks actually much more normal. And it makes sense, like the yield is the total mass of the plant. It's kind of a 3-dimensional thing versus we were looking at comb length before, which is 1-dimensional. Right, so this is something that goes up exponentially as the plant is healthier and bigger. Versus another 1-dimensional trait is comb diameter. Let's do this first one, which was the diameter of the stem at its base, essentially. Right, and that's more normal without being transformed. Okay, if you're in a big hurry to get on with your data analysis, you can probably skip the rest of this video. But otherwise, I'm going to show you a few more useful commands for exploring your data frame. So in my script here, I'm going to do what's called a comment, or start with a hash symbol. And then I can just write for myself a description of what's going on. So feel free to use lots of comments in your scripts to explain to yourself why you're doing what you're doing. Okay, so one useful command is nrow. So if I run that on my data frame, it tells me how many rows I have. So we also saw that when we ran the summary function, and we can see it in our environment pane in the upper right here. But as you get more into programming, you might want to have that number by itself to use for something. Likewise, I can do ncol for number of columns. And I see that I have 20 columns, as we saw from str and as we can see in the environment pane. I can also extract the names of my columns by themselves using call names. Right, and then it tells me the name of each column. And as you recall from before, I had something a little funny happen with data import, and the first column name plot has some characters inserted at the beginning of it that I'd like to get rid of. So I showed you just a little bit of indexing with square brackets before, and again, there'll be a whole video on that later. So if I type square brackets after that, and I type 1 because that's position 1, then I just extract that one. And if I want to change it, what I'm going to do is make an arrow pointing at it, kind of like I did way back when I imported my data frame, so that's a less than sign followed by a hyphen. And then I will type in quotation marks and then the name that I want the column to have. So I'll just type in plot. And so then if I run call names again, now it's been corrected. So now it will have the name that I want. And I can even see that now if I go back and redo str and scroll up, yeah, I see that the name of the plot column has been corrected. Now there is also a row names function. In this case, because of the way we imported the data, the rows are just numbered based on what the row number was. But once we get into more advanced ways to make data frames, you might find this row names function to be useful. Okay, a couple other useful functions for looking at data frames. There's one called head. In fact, this is one that I use a lot when I first import data. And what that does is that shows me just the first 6 rows of the data frame, and it shows all of the columns for that. Similarly, there's a tail function, and that will show me the last 6 rows. Now what if I want to look at something in the middle? So I was showing you the square brackets that we could use on a vector. We can also use square brackets on the whole data frame. So I'm going to type the name of my data frame, followed by square brackets, and then say I want to look at rows 5,000 to 5,010. I'm going to type 5,000, and then a colon, and then 5,010, and then a comma. So before the comma, we put what rows we want, and after the comma, we put what columns we want. So here I want to see every column, and so I'm leaving it blank. That means that every column will be displayed. So then if I do that, then I see those 11 rows. If I did want to also subset it by column, I could do that here. So say I wanted the first 8 columns, and now it just shows me the rows that I specified and the columns that I specified. Okay, so now that you're done with this video, what I recommend looking at next is there's a video on making graphics using ggplot, and there's a video on doing some simple statistics with your data.